All right, welcome back, Prep Station Physics. Yeah, we are still on what is wave, and the next section we're about looking at describing waves. I've just explained what wave is all about using two categories of description, that is material for propagation and the direction for propagation. Let me do a little recap on that. First, I started by saying wave, okay, is disturbance traveling through a medium. Is a disturbance through a medium, and the purpose of that disturbance is to do what? Transfer energy from one point to another. I took time to explain what disturbance is. I also took time to explain what medium is, and then we went straight into description of wave using material for propagation as well as direction for propagation. And then under material for propagation, I mentioned two things. Number one, I mentioned mechanical waves as waves that requires material medium for propagation. I also mentioned electromagnetic waves as the type of waves that does not require medium. That means it can be transmitted through vacuum. And then we also look at direction for propagation, which I mentioned transverse waves, which travels perpendicular to the direction of propagation. I used the guitar to explain that. And then lastly, I explained what longitudinal waves is all about. So in this section, let's quickly look at what are the common terms used in describing waves. Common terms. Okay, we need to understand some common terms used so that as we progress further into properties of waves, and then looking at types of waves as well as standing wave, traveling waves, and all of that, then you'll be able to understand what we'll be doing as we progress. So some of the common terms we are going to consider is amplitude. We are going to consider wavelength. We are going to consider frequency. We are going to consider period, the speed, and all of that. Now, let's look at this diagram once again. I know you have seen this diagram. I told you I will be coming back to this diagram to explain what this diagram is all about. Now, if you look at the top here, where you have the peak of this wave, this is called crest. If you don't want to call it crest, you can also call it peak. Okay, let me write it there. You can also call it peak. And then down this diagram, you have the trough, okay? And then up here, this green line represents the amplitude, the height. The purple line here represents the rest position. And on my left, you have the displacement. The unit is meter. And then on my right, you have the time. So this is transmission or propagation of wave motion traveling with respect to time. Let's start from the first one here before I go into all of this. Now, the highest point of vibration of a transverse wave is known as crest. If you don't want to call it crest, you can also call it peak. It's okay. So the highest point of vibration is called crest. And then the distance, a measure of the distance from the rest position. What is rest position? Look at this point. This is the rest position where I just put a dot now. Rest position means the point where the wave particle keep going to and fro, back and forth. That is the rest position. It is also the point where if you allow this wave, that is to say, if you remove the pulse or remove the disturbances, that wave will come to rest at this point, okay? So the distance from this point that I've marked here to the highest point of this wave is what is called amplitude, okay? This height here is called amplitude. And what is amplitude? The maximum displacement of wave from rest. So this is the highest that this wave can go if it's transmitting upward. Now, the same thing applies to the trough, okay? The trough is just almost the same thing as the peak, just that is on the other side of the graph, okay? You can call it the negative side or you can call it the back and forth side, okay? It's just the opposite, just that is down while this one is up. Now, I've explained what is rest position. Now, what is wavelength? Now, in wave cycle, okay, we consider two measurements there. One is the total distance traveled by the wave, and then the other one is the distance traveled by a cycle of the wave. What I mean by a cycle is in a bit of one vibration, okay, one vibration, one oscillation, one cycle. The distance covered in one cycle is what is called wavelength. And from this diagram, we can also define wavelength as what? The distance from trough to trough, as you can see. So this distance marked here from the trough to trough is wavelength, or you can simply say wavelength is also defined as the distance, marked from crest to crest. Okay, I've given you three definitions for wavelength. One is the distance between two crests. Two is the distance between two troughs. Or three, wavelength is the distance covered in one cycle of waves. Cycle, when I say cycle, I'm referring to what? Oscillation. I'm referring to what? Vibration. Okay, let's move forward. Let's move forward from here. All right, now let's look at describing wave, common terms used. So what is wavelength and what is amplitude? I've already explained. Wavelength of a transverse wave. Wavelength, it is the distance between two consecutive points. That is another definition. I gave you three before, but this time around, I'm making it more precise. It is the distance between two consecutive points. Now, this last definition will help you in terms of calculation. So you don't have to depend on it has to be crest to crest or it has to be trough to trough. No, it can be the distance between two consecutive points. Two identical points on the graph can be referred to as wavelength, because two consecutive points is also equal to what? The distance traveled by one cycle of wave. Now the symbol for wavelength is lambda. This symbol you are looking at here, let me mark it. So this symbol is the symbol, the notation used for what? Wavelength. And the unit of wavelength is simply meters. Meters, M-E-T-R-E-S, meters, as in length, okay? Now let's move forward. What is amplitude? I explained before, but let me still do that again. Amplitude denoted by the alphabet A. Some textbook can use lowercase a and some textbook can use uppercase A, but just know that it's A. What is amplitude? It is the half height of the wave. This is another definition. I told you before now, it is the height from rest position to the peak or from rest position to the trough. So you can also add this. It is the height, half height of the wave. The bigger the amplitude of the wave, the more energy it has. That's true. The energy of any traveling wave corresponds to what? The amplitude. Okay? The amplitude. The energy of wave depends on amplitude. So a larger sound and a smaller sound is all a function of what? Amplitude. Okay? So amplitude determines the energy of the wave. Now let's move forward. I'm just describing the terms. I will still come back to look at all of this again. I really want you to understand what wave is all about before we move deeper into other things. Now, what is frequency? Frequency, the number of waves passing a point each second is called frequency. The number of waves passing a point each second is called frequency. The number of waves. Now, it is denoted by the alphabet or symbol F, lowercase f. And the unit of frequency is Hertz, H-E-R-T-Z, named after the scientist Frank Hertz, okay? It is called Hertz. Now, frequency is the number of waves divided by the time. Now, let me put this into calculation. Look at what I'm going to do on my screen now. If F is for frequency, and by definition, frequency is the number of waves. So if we represent number of waves with N, and then divided by time, if we represent time with T, so this automatically will give us the formula for frequency. So you can see where the definition is coming from. The number of what? Waves passing a point in 1 second. Now, a very precise definition is what? the number of oscillation made per second. Okay, let me write that down. I keep using the word oscillation. You can use the word oscillation, you can use cycle. Let me write it down because I'll be using them interchangeably. Oscillation, cycle, or vibrations. So any of these three words, they are one and the same thing. So frequency is the number of cycle made in 1 second. The number of cycle made in 1 second. All right, let me go back to this. I want to show you something quickly. Okay, now from my definition, I hope you'll be able to answer this question. Now, if the wave below passes a point in 1 second, what is its frequency? If the wave you're looking at below passes through a point, what will be the frequency? All right, let's count the number of waves first. If we count the number of waves, then it will be easier for us to know how many waves are there. Now, how do we count this? You can count from the number of crests, you can count from the number of trough, you can count from 2 identical points or 2 consecutive points. Now, one of the ways to do this, just look at this now. If you follow this wave, this is one crest, and then you stop here. See where I've marked with the red ink. And then if you follow this other one and stop here, there's a cut here. I hope you can see it. So this is half, this is half. And half plus half is what? Is 1. So from this point to this point, that is 1 cycle. That is 1 oscillation. That is 1 vibration. Now let's take it again from here. This is half, and then this is another half. So if you join this again, it means we have 2 cycles here. Now, if you continue like that to this point, then you will agree with me that on this diagram, we have 4 cycles, okay? What is the definition for frequency? Number of waves passing a point each second. So this is a point. And how many waves are in this place? 4. So since I have 4 waves passing through this place in 1 second, it means the frequency of this wave is what? 4 hertz. That is how to do calculation of wave. Now, if you actually got that, then try this. Try this. Now, I have a table here, and I want you to fill this table. I'll be doing it with you. Now, on my left hand, you have wave. So you are going to count the number of wave here. Then the second column, you have the cycle. So you have to count the wave and then determine the number of cycles. You have the time as 2 seconds for each of the row. So what will be the frequency based on the definition I gave you? What is the definition? Frequency is the number of cycles passing a point at each second. Now, let's start with this one. The first row, how many cycles are here? Now, let's start from here. If you take it from this point to this point, that is 1. If you take it from this point to this point, that is 2. Let's continue. I hope you are getting it. If you take it from this point, half, that is 3 cycles. And then if you take it from this point, half, that is 4 cycles. And then if you take it from this point, half, what is that now? That is 6. And then let's check that again. 1, 2, 3, 4, 5, 6. So we have 6 cycles here. So under this column, I'm going to write 6. So let me write it here, because I'll still bring up the number later. So this is 6 cycles. I hope you got that. If you do, then use the same method to check how many cycles are in this second row. So let's count it together. Half, this is 1. Okay. Continue, this is 2. Continue, this is 3. Continue, this is 4. I want to believe you know how I'm getting this. That is half, 5. Half, that is 6. Half, that is 7. Remember, half plus half is 1. Then half, okay, 7. Half, 8. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 cycles. Okay. Now, the third row, how many cycles do we have here? Now, if you look at this, from this point to this point is half. From this point to this point is another half. So 2 halves, that will give us 1 cycle. So now we have the number of cycles. How do you determine the frequency? Go back to the formula I gave you. What is the formula? Frequency is equal to number of cycles n over what? T. Now apply that to this table. Now for row 1, if the number of cycles is 6 and the time is 2, so what will be the frequency? Simple calculation, divide 6 by 2. Now 6 divided by 2, that will give you what? That should give you 3. I hope you are getting that. Okay, so look at the solution. So this is the complete table, and then 10 cycles divided by 2, you have 5. Okay, this one was the last row, the third row was 1 cycle, 1 divided by 2, 0.5. I want to believe you got that. It's very simple. Number of oscillation, number of vibrations, number of cycles divided by the time, that will give you frequency. Now let's move forward to other parameters. Wave speed. Okay, let's take it back. I've explained what is amplitude, I've explained what is wavelength, I've explained what is frequency, and I've shown you the formula and how to do the calculation. Okay, now is wave speed. What is wave speed? Very simple. Just like in your normal definition of speed. Okay, speed is what? Simple. Distance divided by time, okay, or displacement divided by time, depending on which one you are referring to, whether speed or velocity. Although for wave, we use these two interchangeably. We can use speed, we can use velocity. But the simple explanation there is distance traveled by wave over time. And when we say distance traveled by wave, not the total distance, but the distance traveled by one cycle. The distance traveled by one cycle of wave. And what is distance traveled by one cycle of wave? Wavelength. Remember I told you that the wavelength is what? The distance traveled by one cycle of wave. So if that is the case, we can go through this formula together. Now in the diagram, 5 waves pass the shipwreck in 1 second. So the frequency is 5 Hz. Okay, fine. Now the wavelength is 2 meters. This means that the wave traveled 10 meters in 1 second. So the speed is 10 meters per second. Did you get that? Let's look at it again. In the diagram, 5 waves pass the shipwreck in 1 second. So the frequency is 5 Hz. The wavelength lambda is equal to 2 meters. So in this example, frequency is 5 and then wavelength is 2. So the speed is going to be 10. Now let me go back. Let me show you something. How do you define speed? In your normal definition of mathematics, speed is what? Distance over time, isn't it? But because we are discussing wave, I'm not going to use D, but I'm going to use wavelength. Why? Because wavelength is what? Wavelength is the distance covered by one cycle. So instead of writing d over t, I'm going to write lambda over what? T. And again, instead of writing this t, I'm going to write uppercase T. Now you might want to know what is the difference between the lowercase t and the uppercase T. Good, I will explain. Lowercase t is the total time, but uppercase T is called period. And what is period? Period is the time taken to complete one cycle. Period is the time taken to complete one oscillation. Period is the time taken to complete one vibration. You see, I keep using these 3 words because you see them, you know, in your questions and all of that. So don't get confused. Cycles, oscillations, vibration is one and the same thing. Okay, so wavelengths over period, and I said period is the time taken to complete one oscillation. And in formula, this can be written as this. T is equal to what? Small t over n. If you look at this, this is just the inverse of frequency. Remember, frequency was written as this, F equals to n over t. So which means the period is an inverted form of frequency. In other words, it means I can write period as what? 1 over F. So if you factor this into this formula, what will happen? If you factor that into that formula, then I can say V is equal to F lambda. where is lambda coming from? Because big T or uppercase T is 1/f. So if you substitute that into this formula, then you have this. So this is how we arrive at this formula used here. Okay, so wave speed V is equal to F lambda. So when we come back, we'll continue from there how to use this formula to do other calculation. Thank you.